Welcome to lesson 12-6 Combinations. Our Indiana Academic Standard is 7.4.5. Our first vocabulary word is a combination. A combination is a grouping of objects in which the order of the objects does not matter. Some good examples of this would be your pizza toppings. If you go into Wooden Peel Pizza and you order a pepperoni sausage pizza, that's exactly the same pizza as a sausage pepperoni. The books you plan to read, if you list out a bunch of books, it doesn't matter the order in which you list them, it's still going to be the same list of books. And a third example would be me putting you into groups. If I put you into groups of 3 and I said Johnny, Melissa, and George are together, that's going to be the same as George, Johnny, and Melissa. It's still the same group. If you need more time to copy any of this down, pause the video at this time. Now we're going to do example number 1, finding combinations. You have one pen in each of these colors, red, green, blue, and purple. You lend 3 to a friend. How many different combinations of colors are possible in the pens you lend? First, we have to list out all the possible combinations, and we've done that here. Next, we're going to cross out any group containing the same letters as another group. We'll put boxes around the ones that are new, and we'll cross out the ones that are duplicate. So the first one, obviously, we haven't used it yet. RGB, red, green, blue. Going down, red, green, purple is a new combination. But red, blue, green, that's the same as the first one, so we're going to cross it out. The next one, red, blue, purple, brand new, so we're going to put a box around it. Continuing down that row, red, purple, green is not new. Red, purple, blue is not new. Now the second row, green, red, blue. We've used those letters. Green, red, purple. We've used those letters. Green, blue, red. We've used them. Green, blue, purple. That one's new, so we're going to put a box around it. We go through the rest of this list. Every single one of these have already been used, so we're going to cross them out. So we end up with 4 different combinations of 3 colors possible. Now this isn't a very practical way of doing these kinds of problems all the time, so we're going to look at a mathematical way of solving these. Pause the video at this time if you need time to catch up. Now we're using a mathematical way. We're at the county fair and there are 10 rides. You only have time for 3 of them. How many different combinations of rides are available to you? We're going to first find the permutation of all the rides, all 10 rides. But for only choosing 3 rides out of the 10. So we have 10 for the first choice, 9 for the second choice, and 8 for the third choice. So we multiply those together. Go ahead and do that on your calculator. And you should have gotten 720 permutations. Now, if we listed all of those out, we'd find very quickly that many of them are duplicates. So that's why we need the bottom part of this. We have to find the number of permutations for the smaller group. Well, there are only 3 rides that you get to go on. So you have 3 for the first choice, 2 for the second choice, and 1 for the third choice, which gives you a total of 6 permutations. So we're going to take the total number of permutations, 720, over the number of permutations of a small group. So we're going to take 720 divided by 6. Go ahead and do that problem. 720 divided by 6, and you get 120. So there are 120 combinations of rides available. Pause the video at this time if you need more time to write down the examples. Now we're going to do the quick check. We're going to first figure out how many different combinations of 2 seashells can you make from 3 seashells. Well, we had 3 seashells to start with, so we're going to take 3 times 2 because we're choosing 2 seashells. That's of the total group. Now we're going to do a permutation of the small group. Since we're only choosing 2, 2 is our largest number, followed by 1. So we end up with 3 over 2 divided by 2 over 1. So our possible combinations is 3. Now we're going to take a look at another example. On career day, an architect, an engineer, a carpenter, and a journalist speak at your school. If you go to 2 presentations, how many different combinations of presentations can you choose from? Now, since it really doesn't matter if you go to the architect first and then the carpenter, or the carpenter and the architect, that's why we have to do a combination. So you're going to 2 presentations. So if you do the total, you're going to have 4 presentations times 3 presentations for your 2 presentations. On the bottom, we're going to do the small group. You're only going to 2, so that's going to be 2 times 1 for our small group. So we have 4 times 3, which is 12, and 2 times 1, which is 2. 12 over 2 is going to equal 6. So there are 6 combinations of the 4 speakers that you could go to. Let's go back. If you need to pause the video at this time, that's fine. Now we're going to go back and we're going to look at that first example we did with the pens. We're going to do a mathematical way of finding the number of combinations. Listing them out, we did, but it's not practical. So we had 4 pens, 3 pens, and 2 pens to choose from for our top total permutations. Now, since we're only choosing 3 pens, that will be the largest number on the bottom times 2 pens times 1 pen. When we do this multiplication, we end up getting a grand total of 4, because on the top we would have had 24, on the bottom 6. 24 divided by 6 is 4. If you'd like to do some sample questions, you can go to phschool.com and do the online quiz of ARA 1206. You can also look to see if I've uploaded an Activity Lab 12-6 that you can complete at home for bonus points. See you in class tomorrow.